Okay, so let's get started. Today we're going to be talking about membrane replacement, specifically what operators need to know for diffusers and how membrane conditions can impact aeration performance over time. We're going to walk through how membranes age, what that looks like in the field for operators, and how those changes affect airflow, energy use, and overall system stability. We're also going to spend some time talking about what to look for, when cleaning makes sense, and when replacement becomes the next right step. The goal here is to keep this practice and focus on real-world operation, things that you could easily recognize and apply in your own system. Um, Next, we're going to do, before I get started, I'm going to take a quick moment to introduce myself and SSI. I've been with SSI for about 16 years now, and I've had the opportunity to work in a variety of roles during that time, including both sales and marketing. As a company, SSI has been focused on aeration systems and MBBR for over 30 years, working across both municipal and industrial wastewater treatment applications. Last year, we were acquired by Ingersoll Rand, and I'm going to talk a little bit more about IR in the next slide. But as a company, we as SSI, we design and supply complete aeration systems and parts, including diffusers, piping, and support structures with a focus on long-term performance and energy efficiency. Just to give you an idea, our with being acquired by Ingersoll Rand last year, it enables us to bring a full wire to water solution to an aeration plant. So before SSI was focused mainly on diffusers and the aeration, but with the Ingersoll Rand acquisition, we're able to now offer blowers, pumps, controls, and other brands. You can see all the brands within the Ingersoll Rand portfolio here. But it's very exciting because we're able to offer a complete solution to our customers, but for the purpose of the webinar today, we're going to be focusing on aeration and the diffusers. So just a quick overview, what we're going to talk about today on the webinar. We're going to talk about different membrane types and where they typically work best, whether that's a municipal or an industrial application, typical lifespan that you can expect. Then we're going to walk through once your membranes start to fail over time and they start to fail, what actually happens and what drives those things that you're seeing. After that, we're going to look at how that impacts things at a bigger level, at a system level. So what that does to airflow, energy use, mixing, other aspects of your system beyond the diffuser itself. And then finally, we're going to talk about replacement versus cleaning and repairs, what that looks like and how to approach that, as well as what options you have, whether you have an SSI system or you have a competitor system. Again, the goal is to keep this practical. Any questions that you have, drop them in the Q&A. We're going to take time at the end to answer them. But we want to keep it focused on what you'll see in day-to-day operations of a plant, what issues an operator might see. Um, One key takeaway that we want to touch on before we really go into the membranes is aeration drives the system, membranes control it. Aeration dominates the energy usage in a wastewater treatment plant. So although when you're purchasing, it might seem like a much smaller part, aeration plays a huge role in the overall operation and complete life cycle costs of the plant. All of the air has to pass through a membrane in order for those tanks to work. Even the smallest increase in resistance at the membrane level, that can translate into higher blower pressure and much more energy consumption than aeration typically consumes. This is why the membranes have such a huge impact on the overall system performance. I included a little diagram here, and the information is from the EPA, but aeration accounts for about 65% of the overall energy consumption in a wastewater treatment plant. Um, Membranes, they don't fail the way a pump or a blower is going to fail. They won't shut down. Slowly over time, they're going to lose performance. Over time, you might see that the membranes stiffen, foul, and they have more resistance to airflow. What does that resistance mean? It means that your blowers are going to have to work harder to push the same amount of air through the membrane. The challenge is that these changes, they can happen slowly. This isn't something that's going to happen overnight. It's not something that's going to happen in a week. It's something that's going to happen over time. So if you're not really paying close attention to those trends, it's very easy to miss that your membranes might be fouling, scaling, and that maybe you need to give them a little attention. This also isn't specific to one type of system. The same pattern happens to both disc or tube diffusers. By the time that, things escalate really further and you have uneven airflow or process issues, energy use has already been creeping up for months, possibly years at that time. I included a few example pictures here, but you can see kind of what a membrane looks like over time. A lot of people they obviously see the membranes and the diffusers new out of the box, but I thought it would be kind of interesting to include some pictures because we don't usually see under the surface and see what they look like. So you can see the disc membrane, it's got some fouling and scaling build up. Over time, the slits can start stretching out or sometimes they can rip. You can also just see kind of the buildup that happens on these diffusers, even though they're on and running, the influent that we're working with still does degrade these membranes over time. And when you're selecting membranes, the type of membrane material that you get really matters. So we've talked a little bit about how they'll age and what happens, but what's important is by choosing the right membrane material for your system, it can determine how quickly they age and what happens during that aging process. Material selection, it isn't really a one size fits all. It really comes down to the plant level. For example, a typical municipal system might prioritize cost and reliability, while an industrial plant, they come to the table with different concerns. They are dealing with more chemicals, oils, higher temperature, so they're going to need something that's a little more resilient, and oftentimes their budgets are a little bit different than a traditional municipal plant. You also have to think about maintenance strategies. Some municipal plants, they don't have an operator on site all the time. Do they need something that's going to last a little bit longer between cleanings? Is it going to be something that's easier for them to clean, something that's easy to maintain? So, really, when you're either an operator for a plant or you're a salesperson looking to spec out a plant, you have to understand the differences and see it from the operator's level. And that's going to help you make the right decision for your membrane. Next, we're going to go into some of the different membrane materials and some of the more common ones you're going to see in the field. So right now, EPDM, generally, when you're looking at a disc diffuser and a rubber membrane, that is going to be the industry standard and what you see most of the time. It's what most systems have been running. It's widely used because it provides reliable performance. It's a cost-effective option compared to some of the more advanced materials. In typical municipal systems, it performs very well, especially where conditions are stable and maintenance is done routinely. Over time, though, EPDM, it's a little more susceptible to fouling and scaling. We're going to go more into the advanced membrane materials on the next slide, but EPDM membranes are going to foul and scale a little bit quicker than some of those advanced membrane materials. Um, Cleaning can help reform it can help restore some of the performance, particularly when fouling is a primary issue, but it doesn't reverse long-term aging or material degradation. Because of that, EPDM is often used as a baseline and for evaluation against other membranes and how their performance changes over time. That baseline becomes important when we compare some of the more advanced membrane materials. So I have some charts on the next page, and basically it shows how different membrane materials perform and wear over time, including new, fouled, and cleaned. EPDM membranes, traditionally for a municipal installation, most people will see anywhere between 5 and 10 years. Just like with membrane selection, it really varies on a case-by-case situation because it's going to depend, even if you have a municipal plant, if you have any industrial flows, that's going to impact the lifespan of your membrane. Are you maintaining the membranes? Are you running them at the right airflow rate? But generally, we would say 5 to 10 years is a very fair number. Again, you're going to have some swing depending on site variations. But next, we're going to go into some of the more advanced membrane materials. So we have our SSI, we offer both PTFE and PEEK membranes. Advanced membrane materials are a really good selection when you want something that's longer lasting or you have more demanding operating conditions. These advanced membrane materials, they do cost a little bit more, but they're typically used in systems where standard materials might struggle. These are very popular in industrial applications where they have higher chemical exposure or environments with more aggressive fouling. Um, Compared to EPDM, these materials are much more resistant to fouling and scaling, which helps maintain a more consistent airflow over time. One of the key differences is also how these membranes behave with cleaning. So you can see in the chart I have here on the screen, we had done some pilot studies. We had the diffusers installed for about 6 months in an industrial application, and we tested their OT performance, both new, cleaned, and fouled. And you can see, so the the differences between the EPDM and the PTFE membranes. The PTFE, once they're cleaned, they perform much closer to their like new efficiency than the EPDM membrane. So that's a huge thing, especially if you're looking for a system that's going to last. Yes, it's going to cost a little bit more money up front, but you're going to see that in operational savings over time. So the benefit isn't just the lifespan, it's how the system performs between cleanings as well. There's other advanced membrane materials, and these are a little more niche for different applications. We also have silicone and polyurethane. They're used in much more specialized situations, but we do see them sometimes. They're not general purpose, but they can be the right choice for the right fit application. Silicone is often selected for its higher temperature resistant or where there's certain chemical exposures that the PTFE might not be as compatible with. Polyurethane, it's different. It's typically chosen in environments where there's more abrasion or mechanical wear versus the EPDM and the PTFE, which have a rubber base. Both materials are used when standard options don't fit the operating conditions that EPDM would be suitable for. Like everything else we've talked about so far, it really comes back to understanding your individual plant and your application. So, you know, what type of influent are you treating? Do you have industrial flows? What kind of maintenance staff you have? So it's a very personalized experience, which membrane is the best fit for your application. Um, Next, we're kind of going to talk about what happens as the membranes age over time. So typically, this is where you're going to start seeing changes in the aeration performance begin to show up. Once your membrane conditions start to change, whether from aging or fouling, it starts to affect how air moves through the system. So you can see, like, as the membranes age, this is a really good example here of a standard EPDM membrane versus a PTFE taken side by side from operation. You can see that the EPDM membrane has a lot more um, a lot more buildup on the surface of the membrane, whereas the PTFE does not. You can also see that the EPDM membrane has stretched out a little bit more compared to the PTFE membrane. As the membrane stretches out, the airflow pattern is not going to be the same. When it fouls over and scales, like you can see in the picture, airflow becomes much more restricted and distribution across the basin, it becomes less uniform. As the buildup builds on the membrane surface, you're going to start to see gradual increases in blower pressure and energy use. And that's kind of what we touched upon earlier, that these changes, they happen slowly over time. So if you're kind of looking at it day to day, the changes are sometimes so minor one day to the next, it's going to be hard to see unless you really zoom out and look at the bigger picture that, hey, maybe my membranes are clogged. Should I start looking at maintenance? Should I start looking at replacement? Um, because of that, it's easier to miss something going on with your membranes versus something with your blower system or your pumps. In reality, a lot of changes in the aeration pattern and the aeration performance in your system, they get tied back to the membrane level, either through material degradation or fouling and buildup. These small changes end up driving much larger system-wide effects, which we're going to go into later on. Um, but we're going to touch now on how the material degrades over time. One of the main ways that membranes change over time is through the physical degradation of the actual membrane itself. As membranes are exposed to constant air pressure and cycling, they can begin to start wearing, especially as the membranes over time, the EPDM ones, they can start to lose plasticizer. That will show up as stretching in the membrane, loss of shape, the slits can stretch out. And once those changes start happening, even if you clean them, if the membrane's stretched out, the membrane's stretched out. Cleaning will remove some of the surface buildup, but you can't get it back to its original shape. As membranes, lose the plasticizer, they can get dry. Sometimes they'll stiffen and dry out. And if once they eventually dry out enough, they could break. The change in the material properties, whether they stretch out or they break or the slits, that is going to impact your airflow. As the membrane as the airflow is impacted, the airflow, it becomes less consistent, less evenly distributed. So you're going to see different airflow patterns on the surface of your tanks. I didn't have a photo of a poor airflow pattern, but I put here, you can see on the grids between the tube diffusers, the airflow pattern is pretty consistent, pretty similar between the different grids. But if you start to have a membrane that's fouling or the air isn't getting through a certain section, you'll see the airflow pattern is going to be less. If the membrane has burst, you're going to see kind of like a big geyser and bigger bubbles coming from those sections. Again, with the exception of like a burst, but the fouling, these changes happen gradually, but they are going to directly impact your blower. They're going to impact your energy costs. The other um, second major way that membranes change over time is through fouling and building and build up on the surface of the membrane. So you can see here, I included two pictures. You can see kind of like the scaling and the calcium buildup on the membrane or the sludge buildup on the membrane. Different ways that the fouling and scaling buildup over time happens can be mineral scaling with calcium or iron, oils, fats, grease, biological growth. These all kind of stick to the membrane and they impact the airflow. What kind of buildup you have and what happens the quickest is really going to depend on your wastewater and operating conditions. So this really ties into the industrial side of things. So, certain foods, they're more oily or they have more fat, or certain applications might have more grease. But you still, even in a municipal application, you're going to see some of this. It just happens at a much slower rate than an industrial application. But as this material starts to build up on the surface of the membrane, whether it's the oils, the fats, the grease, or calcium buildup, it's going to start restricting the airflow through the membrane slits on the surface. Those, once you start restricting the airflow, it increases the resistance, which means the system's going to need more pressure to deliver the same amount of air. It's basically going to be harder for that membrane to engage and the slits to open. This also over time is going to start causing uneven airflow distribution since air is going to start moving towards the path of least resistance. So if you have two membranes, one of them's a little more clogged than the other, naturally the airflow is going to go towards the one that's least clogged. But over time, that one's going to start getting more airflow and you run the risk of that one stretching out a little bit more. Unlike material degradation, when the membrane starts to stretch out or the slits stretch out, fouling is something that can often be addressed through cleaning, but only up to a point. Cleaning, there's a few different methods of cleaning that you can do. You can do acid dosing. Some operators will actually take down the basin and scrub the diffusers clean. But when you clean them, a lot of times they will return pretty new efficiency during operation. Next, we're going to talk about what an operator should watch for in a field. So how you're going to know that you have some aging or some fouling going on with your membranes. Um, these are the so we're going to go through a list of some things that operators can look for as membranes begin to age or foul. One of the most common indicators is a gradual increase in blower pressure, which we've already touched on, but a gradual increase in blower pressure, even when the airflow demand hasn't changed, is one of the earliest indicators that you have some buildup on your membrane. Along with that, you're also going to see once you turn up those blowers, you're going to see a higher energy use to achieve the same level of aeration. So if you have to start turning your blowers up higher and you're spending more on electric costs, but you're not really treating more efficiently, that's a sign that there is something going on with your membranes. Changes in bubble pattern, they're also another key signal. So I showed that photo before with the tube diffusers in operation, but that was what they look like new. But as they age over time, you might notice larger bubbles, uneven distribution, or reduced bubble density in certain areas. If you see any of those, that's an indication that your membranes might not be operating as originally intended. Airflow, it also can become even uneven across the basin with some areas getting more air and others less. So you might see dead spots if you're looking at the top of the basin, you might see some areas where there's big geysers, like excessive airflow coming through. That's another sign that things are not being distributed evenly at the subsurface level. Um, if you have those uneven airflow patterns and those changes in bubble patterns, that's also going to lead to inconsistent dissolved oxygen readings. So that's another way you can start to spot that, hey, maybe I have something going on. Over time, you also are going to see some areas where mixing is reduced and you might have some sludge start to accumulate. If you have MBBR media in the tank, you might notice that the media is not mixing properly. These changes, again, they don't happen overnight. So they start gradually, which is why membranes and cleaning and efficiency on the membranes is something that's very easy to overlook. Um, Beyond what you should watch for, as there's also an impact on the oxygen transfer efficiency. So your basins are not going to operate as effectively. As the membranes begin to degrade and fouling builds up, oxygen transfer efficiency, which you'll often see referred to as SOTE, begins to decline. What this means is that the air being delivered into the basin is less effective as transferring oxygen into the water. To maintain the same DO levels, the system is going DO or dissolved oxygen. The system is going to have to compensate by increasing airflow. That's what we mean by saying you're going to have to turn up your blowers. Once you turn up the blowers, your energy costs are going to go higher because those blowers cost a lot of money to run, and this is where that 65% of the energy consumption falling into the aeration tanks comes in. So even though your airflow may appear consistent, even, if the patterns on the top of the tank look consistent, they look okay, the efficiency of your air still could have decreased if you have to run more air through the blower to get the same impact. That's how membranes really have such a huge impact on energy use across the system. Um, Next, we're going to talk a little bit more about what happens when the airflow becomes uneven across the basin. So as the membranes foul and degrade, they don't all behave the same way across the system. Some diffusers will require more pressure to open. That could be because they're fouled or scaled, and others may open more easily. So when we say open more easily, that could mean that the slits have stretched out. So if one side of the membrane starts to foul a little bit, the airflow is going to go towards the other side. And if you push more air than you should through a certain membrane, the slits are going to stretch open. Um, Once the slits stretch open, that's really when that membrane starts to stretch a little bit more, loses its shape, loses its efficiency. But overall, the one thing about airflow is it is going to follow the path of least resistance. So whether that's larger slits, a clogged surface, the air is going to go and escape in the easiest point. So instead of being evenly distributed, the airflow becomes uneven across the basins as you have those inefficiencies between the diffusers. That's going to give you areas that are over aerated, which leads to wasted energy, areas that are under aerated where oxygen levels in the tank can drop. In the low aerated areas, mixing is also reduced. That imbalance is going to impact both process performance and overall system efficiency. On this slide, I included an example here. So this was actually, we had a contractor where we went to site. This was a new installation, but they didn't, when they first put the pipes in, we caught it before they officially started up, but the pipes weren't level. So in this case, the airflow was taking the path of least resistance, which the pipes, if you're looking at the T, so the diffusers that are activated towards the center, those are lower, whereas the diffusers towards the end of the pipe run, those are higher. So because the pipe wasn't even, the airflow is taking the path of least resistance, and only those first few diffusers are activated. This is pretty similar to what's going to happen once things get fouled and scaled. So you'll see some membranes will be activated running fine, and then other ones on the end, they're not working, they're not engaging. So it's very similar to what's going to happen with the fouling and scaling. That you're going to see some of those areas are active and engaged, and other ones are not running. What does poor mixing lead to? Poor mixing leads to process instability. As airflow becomes uneven, it doesn't just affect the oxygen, it also impacts mixing within the basin. In the areas where the airflow is reduced, the upward velocity from aeration decreases. That's going to reduce mixing energy and allows the solids to begin settling out of suspension. Over time, what does that mean? You're going to start having sludge accumulating in low energy areas like corners between the grids along the walls. As sludge builds up, these areas can lose oxygen and potentially go septic, leading to odors and other much bigger process issues. Over time, the other parts of the basement may be over aerated, which wastes energy, but even though you're over aerating those areas, it doesn't solve the imbalance. So it doesn't make up for those areas where the airflow is lower. The result is going to be inconsistent treatment performance across your basin overall. So you're not only energy inefficient, but your treatment process isn't going to be efficient. We're also going to talk a little bit about when do you know whether your issue requires just cleaning and maintenance, or should you be looking at a full replacement? Not all performance loss means you need to replace the membrane. If the issue is primary fouling or scaling, cleaning can often help restore the performance of the diffuser. There's a few different ways you can clean the membranes. One of the easiest methods is acid cleaning for mineral buildup. So that will involve putting an acid dosing system on the header pipe and you're cleaning the membranes from underneath. There's other chemical cleaning methods. Again, I mentioned earlier, some operators, they'll physically take the basin offline and they'll manually clean the diffuser. This obviously isn't an option for every operator, but this is also a good way to check the components of the system, see that everything's running correctly, make the repairs that you need to. Some operators will also opt to install a retrievable grid, which makes cleaning much easier. So instead of the grids being fixed to the floor, they are either on a winch or they can bring in a crane and those grids will lift out so they can pull the diffusers out, clean them, check them for maintenance. So there's a lot of different options. And I mean, again, this is something that's going to depend on your individual site conditions. Do you have maintenance? Do you have retrievable grids? But there's a lot of different options, a lot of different ways to look at this. Um, in many cases, just cleaning the membranes can improve airflow and reduce that pressure buildup that you saw on the blowers in the short term. It can also bring back some of those energy costs. So if you saw, you're spending a lot more money on power because your membranes were fouled and you were having to turn up the blowers, if you clean them, you very likely will see a reduction in the energy consumption of the basin. Um, However, cleaning does have its limits. It doesn't reverse some of the material aging that we talked about. So, like the stretching, when the slits come apart, if the membrane splits, things like plasticizer loss. Cleaning the membrane is not going to reverse those things. When the membrane has degraded or when the performance does not recover after cleaning, replacement can become necessary. So, the key distinction to know whether should I clean them or should I replace them is cleaning can restore the performance. Replacement restores long-term system performance and stability, and replacement is something that we would recommend when the actual membrane is damaged beyond a point of cleaning. So when it's stretched out, if the slits are stretched out, that's when you should really start looking at replacing the diffusers versus just doing scheduled maintenance. Um, when membranes reach the point where cleaning is no longer effective, replacement is how you can bring the performance back to its original condition without installing a totally new system. With new membranes, airflow resistance is reduced, which is going to lower the blower pressure and the energy demand. So you're going to go back to that like new efficiency when you first installed the system. You also are going to regain uniform airflow distribution across the basin. So any of those dead spots you saw, any of those over aerated spots you saw, by replacing the membranes, you're going to fix that issue and it's going to restore consistent bubble patterns and oxygen transfer. Again, it's going to restore it back to the way that system was designed when you first installed it. The improved airflow, it's going to help restore mixing, help keep the solids in suspension, and stabilize any DO levels that were uneven across the tank. So rather than just slightly improving performance, a membrane replacement can bring the system to how it was originally designed, how it was originally shipped to you. Um, Membrane replacement, I put together a little slide of just kind of what to expect if you are going to replace your membranes. Once the replacement is planned, the process itself is very structured and repeatable. The first thing that you're going to want to do is turn off the air supply and lower the basin level so the diffusers are accessible and you can get to them. From there, the disc diffusers, this is more focused on the disc diffuser for the replacement, but this is also applicable for tube diffusers as well. You can replace the membranes on a tube diffuser. But on a disc diffuser, basically you just want to take the ring off and it's important to be careful. If you do break the ring, replacement rings are available. Once you get the ring off, you want to take the old membrane out of the base. You're going to want to clean it, get any sludge, any buildup off the base before you put the new membrane on. If you don't clean the base right, it can affect the seal of the new membrane. So it's really important that you're very thorough while you're doing it. Once the new membrane is installed, you just want to make sure that it's seated properly. Once it's seated properly, you put the new ring on, seal it, put it in place, and then you're ready to go to the next one. Um, Once the installation is complete, we recommend filling the basin up a little bit, turning on the airflow pattern, just making sure before you fill the basin back up all the way that there are not any leaks and that the bubble pattern is consistent. If you see any leaks or the bubble pattern's inconsistent, you might have a membrane that's not seated correctly on the base. You might have a ring that's not tightened. Finally, once you get that new basin online, it's important to take some measurements and just establish a new baseline for system pressure and performance so you can watch and you know when these new membranes may also have to be maintained. Tube diffusers, it's very similar. So we also have membranes for tube diffusers, both ours and competitors. But for replacing a tube diffuser system, replacing the membranes, you're going to want to take off, there's a clamp at each end of the diffuser. You take off the clamp, pull the old membrane off. Again, you want to clean the body just as you would have to do for a disc diffuser. You put the new membrane on and reattach the clamps, and then you're going to want to do the same set of checks before you put the membrane or before you put the basin back into operation. Um, when done properly, it's an easy maintenance activity that is going to restore your system performance. And then just to go into some of your retrofit options, our membranes are compatible with competitor systems. So if you are looking to replace the membranes in your system, it's not limited to the original equipment manufacturer. And also, you don't have to replace an EPDM membrane for another EPDM membrane. We've seen a lot of sites where their original scope of supply was an EPDM membrane, and then when they go in for membrane replacement, they're like, hey, you know what? I want to try another option and see how it works. So you can also, when you're replacing your membranes, you can upgrade your system, and that's something that we see a lot of plants do. Um, in most cases, membranes can be replaced across both disc and tube diffuser systems. Again, we have a variety of different sizes and shapes. They fit our bodies, they fit competitor bodies. We can also do upgrades we've also done upgrades to ceramics. So we have some customers that have really old ceramic diffusers. We can supply a base plate and a rubber membrane, and they're able to keep the piping, keep a lot of the more expensive equipment, the supports, other things in the tank, and just upgrade that membrane. So it's like you're getting a new, more modern system by just replacing the membranes. Um, what it really means in practice is you don't have to upgrade your whole system to improve your performance. Just changing out the membranes, you can see a huge difference. This is a really practical way to modernize the aeration performance with minimal disruption to operations and also a lower capital cost for systems. So again, today's objective was just a quick overview on different membranes, different options, replacement, things you're going to see over time and over operation, what to watch out for. That's what I have for you guys today. So I'm going to open it up now